Sum and difference formula for sine and tangent. Pretty straightforward definitions down here, or formulas. Sine of A plus B, two different angles, A and B. Sine A cosine B plus cosine A sine B. Sine of A minus B, expanded out, our formula is sine A cosine B cosine A sine B. Notice, different from cosine, that we have what I would assume or call the same operations or expected operations in here. For a sum, we're going to add our two products together, and for our difference, we're going to subtract our two products. Tangents, where we're going to run into a little bit of work. Again, if we're going to add two angles, tangent of A plus B, the expanded form here is in a fraction. So between the fractions and the radicals here, we're going to have a little bit of extra work to do here to simplify our fraction, but we'll see that a little bit later. Reading through here, the tangent of A plus the tangent of B over 1 minus tangent A times tangent B, noting that we're multiplying these two together. So I'm going to assume we all know our order of operations, so we multiply these before we add or subtract from 1. Then tangent A minus B is tangent A minus tangent B over 1 plus tangent A times the tangent of B. Again, noting order of operations, multiply before we add. I'm going to jump straight into our example here. To get the sine of 75 from our unit circle, we could add 45 and 30 together. So I'll expand that out into the formula up above, which would be a sine of 45 times the cosine of 30 plus the cosine of 45 times the sine of 30. And again, just noting up here, that's the same thing that we have right here. Just in place of the A, I have 45, and in place of the B, I have the 30. Those are my two separate angles. Now we go to our unit circle, make our substitutions. The sine of 45 is square root of 2 over 2. The cosine of 30 is the square root of 3 over 2. Cosine of 45 is square root of 2 over 2, and the sine of 30 is 1/2. Noting that these look very, very similar to our work with cosine because we are using the same values. Also noting here, I'm going to shortcut this a little bit. They're both going to have a denominator of 4, 2 times 2, and 2 times 2. So here my first numerator is square root of 2 times the square root of 3, or square root of 6. My second numerator is 1 times the square root of 2, or square root of 2. So you can see our answer looks very similar to one of our cosine answers from our previous section. Square root of 6 plus square root of 2 all over 4. Tangent of 7 pi over 12. Much like we did with our previous one, I'm going to suggest that we go ahead and convert this to degrees to make it a little bit easier to work with. I'm going to take 7 pi over 12 off to the side and convert it to degrees by multiplying by 180 over pi. The pi's will cancel. The 12 goes into the 180 15 times, and we're actually finding the tangent of 105 degrees. From our unit circle, we could take the tangent of 45 plus 60 to get to that. I'm going to go ahead and expand that out up here. That would be the tangent of 45 plus the tangent of 60 over 1 minus the tangent of 45 times the tangent of 60. Again, going to our unit circle, we would have the tangent of 45 is 1. The tangent of 60 is square root of 3. The tangent of 45 is 1, and the tangent of 60 is the square root of 3. Again, backtracking on my statement about multiplying our order of operations, we don't do 1 minus 1 to get 0. We have to multiply these and then subtract from 1. So my actual fraction is 1 plus the square root of 3 over 1 minus the square root of 3. Now, if you recall from our work way back in Algebra 2, we can't have a radical in the denominator. We all know that. But we multiplied by something called the conjugate. So to get rid of our radical in the denominator, we multiply by 1 plus the square root of 3. The same term, but we switch the operation in between those two terms, because when we do the FOIL process for that, with conjugates, the outer and the inner will cancel each other out, and we'll just have the first and the last, and that will get rid of our radical for us. If we multiply the denominator by something, we multiply the numerator by the exact same thing. So I'm going to start with my denominator here. 1 times 1 is 1. Negative square root of 3 times positive square root of 3 is just 1 minus 3. I am going to go ahead and FOIL my numerator, first, outer, inner, last. So first terms 1 times 1 is 1. Outer terms 1 times square root of 3 is square root of 3. Inner terms 1 times square root of 3 is square root of 3. And last terms square root of 3 times square root of 3 is square root of 9, or just 3. Some more simplifying to do. In my numerator, I have 4, or 1 plus 3 to be 4. Square root of 3 plus square root of 3 is 2 square root of 3's. And then 1 minus 3 is negative 2 in my denominator. Notice that all of our terms could be divided by the negative 2. We could just distribute the negative 2 up top, and that would get me a negative 2 minus the square root of 3 for our simplified tangent answer. 2 minus the square root of 3. So you can see tangent was a good little bit more work because of those fractions and those radicals in the denominator, on top of having a plus or minus sign there in the denominator. So a lot of multiplying by the conjugate. Let's go one more time here. We have the sine of 195. We'll go ahead and add a couple angles here together. Let's go 60 plus 135. If I expand that out, I have the sine of 60 times the sine of 135 plus, oops, let's try that again. I got kind of in a hurry here. Sine of 60 times the cosine of 135 plus the cosine of 60 times the sine of 135. Now we'll go ahead and make our substitutions. The sine of 60 is square root of 3 over 2. Cosine of 135 is negative square root of 2 over 2. The cosine of 60 is 1/2, and the sine of 135 is the square root of 2 over 2. And if we multiply that out, we'll have negative square root of 6 plus square root of 2 all over 4. Now you might see that rewritten as square root of 2 minus the square root of 6 all over 4, but honestly either answer is acceptable there to simplify that down. So one more time here, notice this one is already expanded out, and we have sine times cosine and cosine times sine. So I'd hope we would all agree that's the sine of A plus B, or in this case, the sine of 40 plus 160. 40 plus 160 is 200. 200 is not on our unit circle, so this is all the farther we will go for this particular problem. And there's a quick introduction to our sine and tangent formulas. Let's continue on here. Our next ones say to write each function as an expression involving x. So these are ones we'll expand out and simplify. Sine of 30 plus x is a sine of 30 times the cosine of x plus the cosine of 30 times the sine of x. One angle there from our unit circle, the sine of 30 is 1/2. The cosine of 30 is square root of 3 over 2. And that's the only substitution we can make. We have two different functions here, so we can't add those together. The one thing you might see, backtrack, honestly, this can be one of our answers right here, but you might see this written as the cosine of x plus the square root of 3 times the sine of x all over 2, since back here they both had a denominator of 2. So either one of those is fine. Probably leave it in this form, but you might see it written in this form as well. Let's move on to our tangent. Tangent of 45 minus 30 is, or minus x, sorry. Tangent of 45 minus the tangent of x over 1 minus the tangent of 45, plus times the tangent of x. Tangent of 45 is 1. 1 plus and 1 times the tangent of x. Once again, noting that we would multiply here first, and that's pretty simple because 1 times anything leaves us with the anything, or in this case 1 plus tangent. So our simplified version here is simply 1 minus tangent times 1 plus tangent. We'll go through that again here. Sine of 180 minus x is a sine of 180 times the cosine of x minus the cosine of 180 times the sine of x. 180 is on our unit circle, so we'll make those substitutions. The sine of 180 is 0. The cosine of 180 is negative 1. So 0 times anything is 0, and negative negative makes us a positive sine of x. Let's keep pushing on here then. We have find the functional values and the quadrant of a plus b. A and b are angles in standard position. Sine of a is 4/5. A falls between pi over 2 and pi, which I hope we would all agree puts us in the second quadrant. Cosine of b is negative 5/13. It falls between pi and 3 pi over 2, so that puts us in quadrant number 3. Over here on the far, let's put it up here. We have angles A and B, and we want to find x, y, and r for each of those two angles. That way when we expand out, we can go ahead and find our sine and our tangent. So from our first angle, sine is y over r, so y is 4, r is 5. We know our triangles, x is a 3. We said x, or A, angle A is in quadrant number 2. So I'm going to assume or hope we would all agree that sine, or the x, is negative here, so negative 3. For cosine of b, negative 5/13, cosine is x over r, so we have negative 5 and 13. Again, if we know our triangles, we'll know that y is 12. We're in quadrant 3, so y is negative in quadrant number 3 as well. So we have a negative 12 for our y value there. If we didn't know that, we could have done the negative 5 squared plus y squared equals 13 squared, done our Pythagorean theorem, and solved that out. But back to here, we want to find the sine of a plus b. That's the sine of a times the cosine of b plus the cosine of a times the sine of b. And since we have x, y, and r identified up here, we can go ahead and make those substitutions. The sine of a is y over r, or 4/5. The cosine of b is x over r, or negative 5/13. The cosine of a is x over r, or negative 3/5. And the sine of b is y over r, or negative 12/13. Multiplying, I have negative 20 65ths plus 36 65ths, or a simplified version of 16 65ths. 16 65ths. Negative 20 plus 36 is a positive 16. With that already done, or the x, y, and r already identified, we can find the tangent of a plus b. The tangent of a plus b is the tangent of a plus the tangent of b over 1 minus the tangent of a times the tangent of b. Tangent of a, tangent is y over x, so we have a negative 4/3. Our tangent of b, again, is y over x. A negative 12 over a negative 5 is a positive 12/5. And we'll have 1 minus negative 4/3 times 12/5. Let's go ahead and do our common denominator here, 15. So that means I need to be multiplied by 3 here, or negative 20. I need to multiply by 3 here, which is plus 36. I'll do the second part in 2 steps. Minus a negative is going to make this a plus. I multiply those two fractions. I have 48/15. I'm starting to run out of space a little bit here, but I'll leave my numerator up here. I'll simplify it to be 16/15. 1 plus 48/15 is 15/15 plus 48/15, or 63/15. And one last step, I have one fraction divided by another, so 16/15 times 15 over 63. The 15s are going to cancel, and we'll have 16/63 as our simplified version here for tangent of a plus b. Letter C says, what quadrant is a plus b in? Well, we said the sine of a plus b was 16/65. We said the tangent of a plus b was 16/63. Notice that both sine and tangent are positive, tangent being y over r, or sine being y over r, tangent being y over x, both of those functions are positive in quadrant number 1. Oh, let's move on. And we can't end without doing one identity. Sine pi over 6 plus theta plus cosine pi over 3 plus theta is going to reduce down to cosine theta. So I'm going to do is expand both of these out in their sum formulas. So sine pi over 6 cosine theta plus cosine pi over 6 sine theta. So that's the sine of pi over 6 plus theta. Then I have plus, and I'll go ahead and expand the cosine out as well. That'd be cosine pi over 3 cosine theta minus sine pi over 3 sine theta. So note that you have to be able to remember our cosine formulas from our previous section. The sine of pi over 6 is 1/2. The cosine of pi over 6 is square root of 3 over 2. The cosine of pi over 3 is 1/2. And the sine of pi over 3 is the square root of 3 over 2. So we substitute our angles, again, off of our unit circle, those functional values right there. So notice that I have a 1/2 cosine plus a 1/2 cosine. 1/2 plus 1/2 is 1. And then I have a square root of 3 over 2 sine and a negative square root of 3 over 2 sine. One's positive, one's negative, so those will cancel out. And 1 times cosine then equals cosine. So we have proved our identity for number 9.